There's also such a thing as a base ionization constant, Kb. And we can use that to find the pH of a weak base solution. So here's a question. What is the pH of 0.05 molar ammonia, NH3, which is a weak base with a Kb of 1.8 times 10 to the negative fifth? Same as the value of Ka for our weak acid. Here's the equation for the ionization of ammonia. The ammonia reacts with liquid water to make NH4+. That is the conjugate acid of ammonia. So ammonia took a proton from the water molecule. What's left over from the water is the hydroxide ion. That's the conjugate base of water. And the equilibrium constant for this reaction is Kb, which is equal to the concentration of NH4+ times the concentration of OH- divided by the concentration of NH3. Again, we'll leave water out because it's a liquid. Making our ice table, the concentration of the solution is 0.05 molar. The initial concentration of ammonium and hydroxide will be 0. Since we're starting out with only reactant, concentration of NH3 is going to go down, and the concentration of NH4+ and OH- will both go up. By how much? By x. On the equilibrium line, we'll have 0.05 minus x, x, and x. So, Kb equals 1.8 times 10 to the negative fifth equals x squared over 0.05 minus x. And 0.05 is much, much bigger than 1.8 times 10 to the negative fifth. So we can make the approximation that 0.05 minus x is about equal to 0.05. So we have 1.8 times 10 to the negative fifth equals x squared over 0.05. If we multiply both sides by 0.05 and take the square root, we get x equals the square root of 0.05 times 1.8 times 10 to the negative fifth. Which gives us 9.49 times 10 to the negative fourth. And that is the equilibrium concentration of hydroxide. And remember, pH equals 14 plus the logarithm of the hydroxide ion concentration. So 14 plus the log of 9.49 times 10 to the negative fourth. Which gives us 10.98. Now, if we had a strong base solution, 0.05 molar strong base, then the concentration of hydroxide would just be 0.05. And the pH would be 14 plus the log 0.05. .70. So it makes sense that a strong base at the same concentration should have a higher pH than a weak base.